Good evening, everybody. So today is going to be our art lecture on decision tree classification. And my name is Yelena. I'm one of the teaching assistants in the data analytics program. You may have met me before if you attended the last session during week 1. All right, so here is the agenda for today. We're going to talk about what is the decision tree method. Then we're going to talk about some data pre-processing that needs to be done. We're going to talk about dividing data into training set and test set. And then we're going to look at the two implementations of the method, all right? And there is a bonus at the end. I'll show you what that is. And of course, there is an opportunity for questions and answers. Now, what data we're going to use for tonight? This data is strategically selected because, well, the data is about the students, and we know the student gender, we know some of their high school performance, we know their health condition, we know their gender, we know their financial marital status, we know how much they pay for education, their class rank, etc. We also know how many sessions the student missed, right? GPA, but our goal would be to predict if the student is at risk, right? Whether the student might be failing the academic program or not, okay? And which actually factors could suggest that the student could be at risk, right? So what we will look at is, we will look at the decision tree classification. So the whole idea is that you want to ask a series of what if questions, if then else, right? And you basically break in the data into the subsets based on answers to if then questions. So you start from the top, right? The very top of the tree is called the root node, and the root node represents all data. So what we need to do is we need to find certain variable, right, in the data that we split on, and we keep on splitting until we reach the root node, the leaf node. So we split on a certain condition, right? We have two nodes in the middle there, and we keep on doing it until we meet the termination criteria. And we're going to talk about the different criteria. But then we're going to look at the dominant, and we look at the leaf node if dominant is at risk or not at risk, right? We look the dominant number of observations that are at risk or not at risk, because that's going to be a class, right? Because that's the whole idea. We're going to look at two implementations. In your this week homework assignment, you looked at the C3, right? You look at the C3, and we're going to do the rpart. So C3 is a conditional inference trees. When it's selecting the variable to split on, and I'm going to show you, I'm going to look at the code too. When it chooses the variable to split on, it's going to run a set of significant tests, right? That's how the splitting is done. Then it avoids the potential selection bias. And also, the plus side is that it does not require the past pruning, right? So the tree is not going to be too much bushy, so to speak, right? It has to do with the stopping rule, because the p-value must be less than 0.05 to split the node, right? If not, then the splitting stops. And also the splitting stops if there are no more variables to split on, or if there is no data. We're going to look at the different conditions. On the other hand, rpart method that we're going to look at, it uses the Gini coefficient method. And it's based on what's so-called the purity. It's going to attempt to bring as much data as possible of the same class to the when it splits, it attempts to find a way so that the data that goes in the node belongs to the same class. It's a Gini coefficient method. Well, of course, it's easier to interpret the result, And then there is additional inside that you can see on a data structure, right, that gets generated. Well, the problem is this approach, the second approach that we're going to look at tonight, it does not work well when the data has, well, it could introduce a variable selection bias, so to speak, when the class variable has an imbalance, right? So suppose that I have perhaps 10,000 students who are at risk and only 100 not at risk. I'm not going to use this method, right? And then it will choose the variable that has many possible splits, right? And also, it may choose the variable with missing values, and this method may require the pruning the trees. On the other hand, the ctree method that you used for your assignment, it may fail if you have an independent factor variable with too many levels. And we look at it. We're going to look at it now. So the data that we're going to look at it has the county. See this? The county is a variable that have many values. So in order to run both of the methods, we're going to need to remove it because it has too many values, right? Then if you look at it, the data sample is from New York. All students are from New York, so we're going to remove column U and column V, right? That's going to be our data pre-processing. Remove column U and column V. In our case, the data has no missing values, but if there were any, with rpart method, it may have been a problem. With C3, probably not, because it does the imputation for you. Okay? Now, I listed the packages that you need to install, and you already did that. For the C3, you had an assignment already, and you installed the party, right? And then also, you're gonna install caret. This is for advanced confusion matrix, right? And those are true for the fancy plots. Okay. All right. So let me go now and start. Okay. Now we're gonna look at the C3 implementation. I'm gonna do the code, and after this session, I'm gonna give you the copy of the code. So basically, what I have to do is, first of all, I need to read my risk students data CSV file into the R data frame. Remember that you have read CSV command, right? But before you even do that, you have to specify the working directory, because otherwise it does not know where to look for the file, right? It does not know. It's pointed at whatever the working directory was set at. Now we use read CSV command. Here is the file name, right? See, this one means that the first row contains the column headings, and it's a delimited file, and then this is very important. You want to set as is false, because you don't want the factor variables to be read as a character, okay? We want at risk, not at risk, for instance, it has to be a factor. Otherwise, trust me, you're gonna get unexpected results. So what we're gonna do, we're gonna read this now, and that created the data frame, right? Now, what you would do in assignment, you would, when you ran this, when you did the assignment that's due this week, you probably installed the party package, but this package has a lot of dependencies. So just in case, you could use dependencies equals true option. So what that will do is that it will install the other packages that the package is dependent on. Now here you have two options. You can do load or you can do require to load the package in memory. Okay, it's done. Now what we'll do is we're going to look at the summary, right? But also, in addition to looking at the summary, I would recommend to look at the str, because you want to see the data types, etc. Right? So let's add this. Okay, I'm not sure. Okay, let's add this. We want to look at the structure, and well, take a look at this county. How many levels is it? 62, right? So this could be a problem. So we need to remove this, right? Everything else could stay as is. Now, this method, and so is the other method that we are going to look at, works well for numeric variables and for the factor variables. You don't need to do any discretization or anything like that. It does it internally, does an internal binning for you. So with that being said, what we'll do is we're going to remove the state because it has only one value, right? Everybody is in New York, and we're going to remove the county, right? So now what we'll do is we have to split data randomly into train and test set. And we do it because we don't want the model to overfit the data, right? We want to evaluate the model on a training set and then evaluate it on a test set. Now, the reason we do the set seed because we want the results to be reproducible. So if we run the whole code 5 minutes later, I want to get the same result, right? So what this will do, it set the seed, and then it will split it into the training and test data, right? So now we are at the step to build our model, and let's look at the parameters that the model takes. First, we need to specify the formula. The formula consists of the target that we want, it's a variable that we want to predict, right? In this case, it's a risk. If student is at risk and not at risk, we put the tilde, and then here we put the we put all of our predictors separated by the plus, right? We can list all variables one at a time, but also we could use a shortcut. That shortcut on the right-hand side means that we use all independent variables as predictors, okay? Then we specify the data frame name, which is a training set, and we're gonna look at this a bit later. We're gonna look at this a bit later. Okay, and for this assignment, which is due this week, you're not asked to look at this, right? This three. But it's something that you might want to consider for the assignment. Okay, so what we'll do now, take a look. I'm running the ctree method and I'm storing the output in the model, right? So this is basically nothing but an, sort of like an R object where I want to store it. Now, see this? It went into here. It's in here. It's a binary, large binary tree data type, right? And look at its size. So, right? So now, wait, let me see. Do I have, okay. Now what I can do is I can print the text of a model into the console window. I just type the model, and this will output the whole tree. Notice that how hard it is to read. So basically over here, what we're doing, each node has a number, right? The root node is numbered number 1, right? And this one, this is showing you the number of absence. Well, this is a splitting criteria. We are checking if we're using the first splitting variable is the number of absences, right? How many times the student was absent. If it was absent less than, if it was absent twice or 1 time or 0 times, we're going to look at infirmary visits, which means how many times the student visited the health center, right? Then we're going to look at if it's less than or equal to 0, which is if it's 0, the student was healthy, then we're looking at the overall GPAs, and we reach node number 4. And here, this one means the number of observations that fall into this node. So basically, if I go in and if I traverse the tree, right, this is the number of observations that fall into this node. Notice that it's a little bit hard to interpret, right? And notice that the criteria, right, 1. Now, see this overall GPA, right? It's the third criteria, and it's a club membership. Well, here, look at this. If GPA was below this, right, then we got to this one, node 4. Otherwise, if the GPA is above this number, then we're looking at the class membership, and etc., right? And then we reach another node. This is a little bit harder to interpret, but also what you could do is you could print the subset of the tree. Okay, so this gives us a subset of the tree. Well, 5 means that I want to see only, I want to see starting from node 5. So I want to print the branch, right? So if I go up in here, see this, the nodes are numbered, and I want to start from node number 5 and do all the way to the, I want to do from number 5 all the way to the terminal node. See this 5, 6? So this is a 5, right? It's 5 was split on a club membership, right? And I want the whole thing starting from node 5. I realize it's a little bit hard to interpret, right? So now we're going to plot the model, and I'll show you different options, because sometimes you want to see the dependent variable distribution at each terminal node. Sometimes you don't, right? So if I do the plot model, it's going to be kind of little bit cluttered and hard to read. So what I would usually do is I try to zoom in. Yes, it's hard to read, but I'll show you what you can do, what your options are. But, well, take a look at this here. What it's doing is this. It's checking the number of absences, right? And the way it is, and I'll show you what you'll need to do to make it a little bit more readable. So here it is, the number of absences. If it's less than 2, right, we look here, and we keep on going, and then we're going to look at our terminal node. We're going to look at the class at the terminal node, and the class that is dominant at the terminal node, it's going to be the class of our student, right? At risk, not at risk. So basically, what I'm trying to say is that if I get a new student, and if I know how many times the student was absent, if I know the GPA, if I know the club membership, and etc., all of these things that I used in here, if I know this information, how do I use this model to determine if my student is at risk? I'm going to start from the top, and I'm going to traverse this tree, right? I'm answering a set of questions. Is my student absent more than twice? Yes. Let's look at the club membership. Let's look at this and this. So now I strategically selected this data set because it shows later on, if you keep on traversing the tree, it shows that if you were absent more than 4 times, you are at risk. So it means that if you miss the discussion, so to speak, 4 weeks or more, it means that you are at risk for not doing well, or something like that, right? So just to show that your attendance is important. Attendance, right, is one of the most important predictors. This is your activity level, and this has to do with your health, etc. So it's not the GPA, right? Well, GPA matters, but it's all the way down the hierarchy, okay? So what we will do now is this. You have several options. You can do plot simple, right? Well, with that, you can read a little bit more because, well, for each node, it's showing you how many instances, and this one, it's also showing you the probabilities of each class, okay? So it's gonna show the percentage, so to speak, right? If you end up on that node, what's the chance that you're going to be at risk, and what's the chance that you're going to be not at risk, right? And what is a dominant class? What is a dominant, right? So here you see the node numbers, and here is a splitting variable name. Notice that it's spelled out in full, right? Node numbers, you see p-values, and etc. You have options to limit what you see, and I'll show you. But before that, well, this is expanded. So basically here, you can see the visualizations, right? And it's a little bit harder to read. So with this big tree, you probably want to see simple, as I did. Now you can further control how the terminal nodes are displayed. Like here, you see how they are? there is an option to bring them, to drop them at the bottom. So let's see, let's select, let's see this, right? I did that, and see all of this appear at the bottom. And I can also do this, simple, and this one is drop terminal fill. So I'm giving you the difference, okay? So now let's see what actually this is doing. There is something called the confusion matrix, or some textbook also call it classification table. What we want to see is that how many students were identified as at academic risk that are actually at academic risk, right? Then we want to see how many students were identified as at risk, but they're not, right? So false positive. Then we also want to look at how many students are at risk, but they were not identified by the method. And also how many students are not at risk, they were identified but not at risk. So let me show you something here. You've seen this in assignment, right? You build the table. Oh, wait a minute. What is this? I forgot to tell you this. Okay, first of all, we need to do the predict, right? For right now, we are taking our training data, right? We are working with the same data that we used to train the model. We are not looking at using the test data yet at the moment. So now I'm going to do this. This is a confusion matrix, but the problem is when I try to read it, I probably would not know which ones are predicted and which ones are actual. So what I recommend doing is that you may add another parameter, DNM equals C, and in here you're going to add the labels. So you're going to label the dimensions of the confusion matrix like this. See this? And it's going to be much easier for you to read as well. So now I can see that column headings means actual and row labels means predicted, right? So here, what I have is that I have 361 students who are at risk and they were predicted at risk, right? Then here, not at risk, predicted is not at risk. So here on this diagonal, those are the correct predictions, right? And those are misclassification. So if I wanted to know what classification accuracy, I would have to take the sum over here on this diagonal, right? And divide by total number of records in my training data, right? So basically, this is just one way to do this. This is just one way to do this because length is gonna return you the number of instances, right? Then in here, you're taking the sum, you're adding up where the predicted, well, here what you're doing is that you're trying to count, you're checking if the predicted value is equal to the actual value, right? You're taking the sum because what's going to happen is this. If predicted value equals to actual value, then it's true, right? And we're taking sum of true, which will return the number of observations correctly predicted. So this is the classification accuracy. Now, sometimes you may think, maybe 89% is too low. But if it was 99, I would be concerned because maybe my model is overfitting too much to the training data. It's not going to do any good when I have a new student and if I try to predict if the student is at risk, right? So for that reason, we're gonna evaluate the model on a test data. And this is what you're gonna do. You use the predict function. You pass the model, right? And then the data is this test data. And then the method class, because you want to predict the class, right? You want to predict the class. So what I'm gonna do now, I'm gonna run this. And this is gonna store the predictions into the test variable. And what I'm gonna do now is I'm gonna do similar confusion matrix as I did before. And I'm gonna add the labels because I want to know what the row is and what the column is. So I recommend, well, at least if not for this assignment, not for this exercise, for the assignment, right, that's due next week, this is a recommendation because it will help you with results interpretation. You know where the actuals are and you know where the predicted are. It just will help you read this. And over here, this is one way to show the accuracy, right? So for good reason, I noticed that it's sort of kind of like the same on the test data or close, which means my model is not overfitting, right? We are good. Now we're going to look at more stuff. Well, C3, this model, it has more options here for the pruning. Basically, what is pruning? Look, section of the tree is called the branch, right? And we keep on splitting, but the thing is, how far do we split? When do we want to stop, right? Because we want to, one reason is to avoid the overfitting, right? And another reason that I'm going to use right now is because I want to be able to read the model. Okay, so this one, max depth, is specified the maximum pass depth at any node. So if it's 5, it means that the distance from any node, right? If I take a distance perhaps from the root node to the terminal node, there should be at maximum five splits, right? So we can specify how the number of splits. This one, mean split, is different. You're specifying the minimum node weight. Remember, weight is a number of observations that fall into that node. So you're specifying the minimum node weight that needs to be considered before the node can be split. So for instance, if I set mean split to 90, right? Or, well, if I set it to 90, then it means that I should have at least 90 to split, right? If I have 80 observations, I'm not going to continue, right? And this one is the minimum sum of weights. So basically, if I look, this is mean bucket, right? So if I look at the terminal nodes, right, I want to make sure that the sum adds up to this, right? Okay. Now, what is pruning? Pruning is removing the subnodes from the decision tree, because big trees may overfit the model, right? So what I did for you, I spelled it out. I explained it for you what we're looking at, right? So absences was the first splitting criteria, then infirmary visits, and the GPA, CSIS, and then the club membership, etc. So if you asked to see which predictors are important, you want to look which ones are used as a first splitting variable, right? Then you also want to look at how many times they're used in a tree, right? You want to look at that. So I would say absences, infirmary visits, and the GPA, of course, club membership. Those are important here. Well, class hours somewhat is. So now let's go back. So here, this is what you can do, the max dash, but look, you have to add, this is a control. This parameter is called control. And then you do the C3 control and you specify which type of control you want to use. In this case, I said max depth is 3, right? And we're going to look at what happens, right? So from any nodes, the farthest depth I go is 3. So this is a root node, right? I cannot go more than 3 down. And if I plot it, it's going to be nice and easy to understand, well, relatively, because I just went 3 levels, right? So now, since it's easy to understand, look, if I have a new student, right, I know the number of absences, and suppose that the student was absent 4 times, I take this pass, right? Then I'm going to look at the club membership. Suppose that a student is member of perhaps 5 clubs, right? Then I'm going to look at the overall GPA, and based on that, I'm going to see it, because see this, the dark area here, it means that not at risk, and the light area is at risk, right? So here, well, this is a sort of like a category of students who are more likely not at risk, right? So this is sort of, so to speak, a profile of students who are more likely not at risk, right? Those are the rules. All right, so when I have a new student, I'm just going to traverse this tree. That's what I'm going to do, right? So, and this is another option in here that we'll talk about. We looked at the mean split, right? Now, well, take a look at this. I have more than 3. I have depths more than 3 because I don't control the depths. I'm rather specifying, I'm rather looking at the weight, right? The number of observations, so to speak, right? And this is the third one, right? Now, well, here, this is how you read the help system for the C3. And you also want to read a little bit about the C3 control. Well, because there are different options. If you want to go beyond, well, here are some options that you could read about and use anything you like for your assignment. Examples 3, just going to show some examples, right? And also VNet party. This package comes with the PDF file. It has a documentation. So I would recommend, if you have time, to take a look at it, okay? It will give you more information on the package, okay? So now there are some additional plot options. This is not in the exercise, but basically, let me explain what's going on. You can change the nodes appearance, because if I go to the plots, well, the nodes over here, the middle nodes, those are also called the nodes inner, right? Those are the nodes inner, and I can change how they appear. Like, for example, I can change the fill color right here. So to do this, I have an argument, right? The plot function has an inner panel argument, and I'm gonna call not inner. Then the input that it takes is this. I can pass model, and then I'll just show you an example. I put a fill, and those are the colors that I want to use. ID equals true means that I still want to show the node number. Here I can control whether I want to show the node numbers. Okay, so let's see what's gonna happen. So, well, this is gonna be, you're gonna see the colors, see? Well, node inner is a way to control how the inner nodes appears. And there are other options, like let me see. Take a look at these nodes. I'm gonna type this help thing, right? And I'll show you more options. If you wanted to, perhaps there should be a way to control the text size and etc. See this, you can decide if you want to show the p-values, if you want to show the IDs, and if you want to abbreviate, and I'll show you that too. Then you can decide if you want to show the box plot, bar plot, etc. Right? You can control the appearance. Now let's look at another example here. In addition to changing colors, I am doing that. I also want to see the ID, but I don't want to drop the terminal nodes, right? I don't want to, that's what I'm doing in here. See this, right? And this is another example. I want to, here I can control, well, the terminal nodes, right? This one, node terminal, is controlling how the terminal nodes appear. And I can choose, I want to fill it white. and I want to remove the ID, node number. I want to not show the p-values, and I want to abbreviate the splitting variable names. So let me run this, and also model type simple. That's what I did. Because sometimes this is too complicated and I cannot even look at it, right? I want to do something that I can see. See this? Now I can see a little bit more what's going on, right? So basically, what I'm saying is that those are the options, okay? It's a simpler version of the plot, but you can control how the inner nodes appear and how your terminal nodes appear. So this is a C-tree implementation that you are familiar with in the homework assignment. Now we're going to look at the rpart implementation. So now remember this from this slide here. Rpart, it has its limitation. Well, it's easier to interpret. Yes, you may see additional insight on the tree structure, and I'll show you, but it doesn't work well when you have a lot of class imbalance, and there could be the variable selection bias. So that's another reason why you want to you want to remove that variable that has many values, right? The factor variable with many values you probably want to remove, because if you don't do it, it's gonna choose it as one of the predictors, and the tree is gonna be a big mess. You don't want to see that. And also, this model this tree may require you to do the past pruning. This method, right? So this is a C-tree method. I'm just showing you the options here, right? So those are the help on C-tree. This is the rpart. Basically, this is almost the same but different. You specify the formula, right? Here, since the trees can be classification and regression, right? You want to specify that method equal class because your target variable is categorical, and also you can do the control. You can control the pruning, right? The formula is the same way. You specify your variables that you're predicting, tilde followed by the predictors, but you can use the dot shortcut, right? You can use the dot shortcut if you want to use all of them. Sometimes it's possible, but later in the next topic, you will see a method where this shortcut is not supported. At least it was not supported until R version 4. I will check version 4 later. Okay, so here you can also run this help, right? You can run this rpart control to get more options here. Okay, so I'm gonna run the code, but first this is a little bit of preview that it's much easier to read this interpretation, because you're gonna get the node number, you're gonna get the condition of the split, you're gonna get the number of observation in a training set that fall into the node, then you're gonna get the number of misclassification. Then you're gonna get the value of the target variable with the highest probability. Like, see this, the root node, right? You're gonna look at it and you're gonna say, not at risk has the highest probability, right? But of course, this one, you can see that this it's unbalanced, right? But let's see how that model performs well. But if it performs well, let's see the performance, because here the dependent variable, well, I would think it's unbalanced, but well, let's see what happens. Never know until we see, right? So we're gonna run rpart, and I'll show you the visualizations too. Okay, so this is going to be a different file. I'm gonna rerun it from scratch because it was written as if you run it separately. So this one, I just loaded the data, right? I'm gonna do require rpart. Okay. We can also do the library command to load.
I'm going to remove the state, and also I'm going to remove the county. Now, same thing, I'm going to split data into the train set and test set. Now, what I'll do is I'm going to build my model method class, right? Because I want to do the classification. I call it model2, and this is rpart, the same variable, right? Prediction. So see this, it's a little bit similar, but it's different. Now I can do this. Look, I printed model2. This is a textual output of the whole thing. And this asterisk, it denotes that the node is terminal or the leaf node. And here, this is showing me the splitting criteria and etc., right? The distributions for each class and so forth. See this? I told you before that if a student was absent 5 times, well, it's usually 5 times, see? For unknown reason, it's treating that variable number of absences. For some reason, it's doing it 4.5. Well, yeah, but anyhow, see here, everybody who is absent 4 or more times is automatically at risk, right? Well, that's how actually this data is. Okay, now I mentioned that you can see additional information, the summary of splits for each node. So if you do this, you get the summary of detailed summary of split, sort of like predicted class and the loss and etc., right? So you get more information on each node. See this, you get the class counts and you get the probabilities and so forth, right? You can also see the variable importance, and you see that absences is a high importance, right? So that answers your questions, which variables are important. Well, you can see, especially ones that are used as a force splitting variable, you want to see which ones are used a lot in the tree, right? So now, if you want to visualize it, there is no simple plot function like this. What you need to do is that you have to use, well, it's a different plot function, so to speak. So first of all, you want to allow labels to show outside the plot region. So this parameter xpd, it's going to control the clipping. So we want to set it equals to true. Well, now you don't see the result, but well, what it's doing, it controls, you don't want the labels to be chipped off, right? That's what it's doing. Now, there are 2 commands. Here, I'm going to plot the model and I'm going to do the compressed. Now, take a look at it. This is how the model looks like. We need to run additional command to add the labels, and we want to, we want to add the counts to labels. Use n equals true, it's going to add the counts to the label. So let me run this. See this? If I do this zoom, I'm going to see this, right? It added the counts. So for instance, this one is not at risk, right? But I want to see how many are at risk and how many are not at risk. So that's what it's doing. And this is not pretty, but it's functional, it's readable, right? Now I'm going to show you alternative method to do this. This is a package, rpart.plot. I'm going to load this. So now what I'll do is I'm going to do, look, when I do it like this, right? See this? This is much easier. I'm going to zoom in. Well, see this? Now I can see this. If number of absences is greater than 3, okay, looks like yes. Now I'm looking at this class membership, right? And if it's club membership, if it's less than 1, this is what I take, right? Otherwise, I take this, right? And it's so on. It keeps on going until I reach the terminal node. But the problem is, I don't know the split. I don't know how many are at risk, how many are not at risk. I don't see enough information here. So what I want to do is, first of all, I want to add the node numbers. So n equals true is gonna add, it's gonna do another, oops, it's gonna add another more information. So see this, I added the node numbers, and I also added this, this one here. See, this was a node number. This is what it did. All right, now close this. Now I'm gonna do this one extra. So extra is gonna add the probabilities to the leaf nodes. See this? I'm gonna zoom in, and this is basically what it did. I added more stuff in here. See, the probability, not at risk, and also I want to look at the percentages, right? I want to look at this. Okay, well, not sure what's going on, but I want to add the probabilities here too. Okay, now let's close this. Okay, now we want to see our model performance, right? So let's look at this. I'm gonna do this table command again. Well, again, this is a little bit difficult to read because I don't know which ones are actual and which ones are the predicted. So what I'll do is I'm gonna add these labels, right? So when you do the assignment, I think it might help you with data interpretation if you do this, right? And this is a way to actually calculate the accuracy if you don't want to use a calculator, right? You can just do this. And also, if you want to make sure the work is reproducible, right? When you rerun the script again, you don't want to pick up your calculator again, right? Now, here, what we're doing, we are evaluating the model on a test set, right? And now I want to see how the model did on the test set, right? So this is the confusion matrix for the test set, right? Oh, not sure why I'm not doing this, but I should have done, I'm missing the line to actually do the calculation, right? So take a look at this. What you have to do is you have to add 141 plus 1491, right? So this is the sum of correct predictions, and I'm looking at the test data, so I have to divide it by 1833, right? I'm gonna go back and I'm gonna divide it by 1833, divided by 1833, right? So it's also 89% classification accuracy. Wow, not bad. Now I'm gonna show you more. There is a different implementation of the confusion matrix. You need to install the caret package for this, and you also need this one, but I think you already used it for naive Bayes in a previous lesson, right? So what you'll do now, I will take the model tools that we did before, and what I'll do is I'm gonna upload these two packages, and I'm gonna do, okay, I'm gonna do this, predict the model for the test data, and now I'm gonna do the confusion matrix, and I'll show you. Well, see this? You have all of these additional metrics, and on the slides, I spelled it out for you. I spelled it out, so let me see. Well, here, positive class is at risk, right? So whatever you see here, it's at risk. It's a positive class. But let's look at this slide where what I did was I spelled it out. Basically, accuracy. What is an accuracy? We want to add the true positive and true negatives, right? Which is, we're looking at the numbers on a diagonal, right? Divided by the total. So this is how accurate it is. Here, we want to look at the true positive to total actual positive sensitivity. So I want to look at how many were actually how many students were identified as at risk or in fact at risk, right? Here, I want to look at how many students were identified as not at risk or actually not at risk. Then in here, I also look at the true positive and that are predicted as positive. I want to look at who is positive, and actually in fact predicted as positive, the negative predicted as negative. And then if I look at the prevalence, I have to take the true positive divided by total number of instances. That's what it's doing here, okay? This is the prevalence. Those are the metrics. Now let's go back to the code. Remember, we looked at the different ways to control the depth of the tree, right? The pruning. Same thing applies in here. The same parameters that we talked about apply here, such as the depth, minimum split, etc. Right? So I'm doing it here and I'm just showing you, right? Okay. Now, here you might be wondering, what is my optimal tree size? What is my optimal actual tree size? When should I stop, right? Well, we can look at something called the CP table. See this? So a model has information such as CP table. And what you want to do is you want to find the relative error inflection point, right? You want to find the inflection point. And inflection point is going to give you probably the optimum number of splits. Like, see this, if I go and if I plot this guy, if I plot this right here, well, see this is an inflection point 6. So basically, it says the optimal size of the tree should be 6. Well, if I go too much, if I go more than 6, then probably my model might be overfitting to the training data. But if I don't do enough, my model might be too general. So the optimal depth is the 6. See this? You want to look at the inflection point. Okay. Next thing here, this is basically the help page that you can check for more information, right? And you also have this. This is a model summary output. Rpart object, you can learn actually what the summary output tells you and different options, okay? Now, I promised you that there is a bonus, and I'll show you this. For this to work, you have to install the color brewer and the rattle package. These two, and they have a lot of dependencies. But what I'll do, this is just gonna show the fancy tree. See this? I do this. Then I'm gonna do library rattle. Okay. Now here, well, this is in red, but this is not an error. It just this message is informative. Okay. It does not say that it's an error. Okay. So now I'm gonna do this first. I'm gonna do the fancy plot. Take a look at this. It just, isn't it just nice? And in fact, that was used to do the plot in a course content. The plot was built in R, okay? So now what I could do here, I could specify the color, and there are many more options, but you can explore the options. This is a web page where you can find more information on this type of plot, okay? So let me see the chat. Guys, I want you to ask me questions right now. As you may or may not remember, we had an introduction to R session, and then you also met me in a data extend course, right? So I really like when students ask questions, and I like students who ask questions because you're telling me that you have been working on the assignment, you have been up to speed with readings and you're looking at this, okay? So yeah, let me take a look at the chat. Is there a rule of thumb when to use rpart versus ctree? Well, this is an excellent question. You want to look at the data set, right? If the dependent variable is imbalanced, right? You want to look at that. You want to look at if you have a variable that has too many, so to speak, that has too many values, like the one I had here, which is a county, right? So that one was a bit of a problem. So there is no right or wrong answer, but you want to, of course, look at your data and you want to keep this table here in mind where I listed the advantages and disadvantages, okay? Well, you know that rpart is a little bit easier to interpret. You see additional insight, but the problem is there is some selection bias, because if you have a class imbalance, it's a problem, right? And a lot of your data sets that you're working with could have a class imbalance. Then it may select a variable to do many possible split, and then you have to do the past pruning, right? So on the other hand, if you, this one also may fail, the ctree may also fail when you have too many levels, right? So basically there is no right or wrong answer. Sometimes, in fact, you want to try different method implementations and see which one performs better, okay? I mean, you trust me, you want to try sometimes different method implementations and see which one performs better and look at the differences also. See this? So this is what we got with the C3, and this is also what we got with the rpart. This is rpart, and it's used absences as a split. Okay. Any conditions to keep or remove? Okay. Anything to keep by condition? You mean remove the variables? Oh, attributes. Okay. Yes. Well, you don't need to explicitly remove the continuous variables unless it's really skewed. This method handles the continuous and categorical variables very well, okay? Well, the only time you have a problem when your categorical variable has too many values. Like in my case, it was the city, right? It was a city. So that's the reason why I removed it. Then I removed the state because this data sample, everything comes from the same state. So that's what I did, right? I did not need to worry about the missing values in my case, right? And both methods did well in my case, right? Well, but as you see it, number of absences is important. So if you're taking class in online setting, probably the number of absences is going to be how many times you did not participate in discussion, right? But this tree is going to be a big mess if I do this and if I run this, right? And if I don't remove the if I see this, I do this, I still remove the state, but I don't remove the county. Now I'm gonna run rpart, and it's gonna be what I don't expect to be, right? Okay, still good so far? Take a look at this. Whoa, 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 take a look at this. What is it doing? Look at what is it doing with all of these cities. Look, see a problem? And then it's gonna keep on going unless I tell it to stop, right? And then if I try to plot this guy here, it's gonna be a mess, right? You will see what it did. Unfortunately, it's gonna take the county as a splitting variable, right? It's gonna pick, the problem is it's gonna automatically pick this variable for the split because it sees too many options, right? And see, even over here, I have the label with 52 levels. I cannot even print it. I can't even print the label in here, see? There are so many issues. You see what happens? And I could also try to do the C3 intentionally, right? So I do this, and then I'm gonna go here. I'm gonna remove the state, but let's keep the county, and let's do this. You're gonna see the problem, right? And you probably want to remove, if the data has unique identifier, then you want to remove it. This will be important in the next week too, because when you do the neural network, it adds complexity. Oh boy, take a look at what it's doing. Take a look at what it's doing. It took the county, right? And it's taking it as a first split. See? This is what it's doing. It's not because it's, well, sometimes it's going to do it because it's significant, but not necessarily. Jesus, I plot this. And, take a look at what it did. Well, with rpart, I would need to do more pruning, but Jesus is going to do way more splits because I have too many values in a county. So I have several options here. I could either remove it or I could group it. I could somehow find a way to do the binning, right? Like for instance, I could do, well, I could find some business rule to do this, to group them. Let me see the chart. Okay. In the C3 method, what does statistic value mean? Oh, okay. So basically, those are the significances because this method is based on it's based on a significance, right? So how important is the variable is? It's an information gain index. Remember, the C3 method. Well, it's a Let me look at this. Like, look at this here. It's showing you, well, it's a significant test rather, so it shows you the significance of the splitting variable, right? It's doing the covariate selection scheme. See, that's what it's doing. And this one is a Gini index, and this one is going to show you the significance because it is yes. Oh, okay, sure. I'm glad that I answered the question. Yes, because look at it. You're looking at the significance. So in here, what it does is that it's making sure that the p-value must be less than 0.05 to split the node. So that's a look more or less. How about what? PL. I'm sorry, I'm not feeling the. I'm trying to understand the question. What's the question? I'm trying to understand. How about what? At the end? Oh, prediction? Oh, that's a precision, right? Precision interval. Oh, the confidence interval? Yeah, that's a confidence interval, I think. I need to look. Oh, wait a minute. Let me see. Prediction interval. Oh, yeah. That's a probability for each class. Let's see. Let me take a look at it. Is it C3? You're talking about the C3? So let's take a look at this. So this is a C3. Okay, so let's take a look at this prediction interval, and which method are we looking at? I'm trying to see. So I'm trying to see. Let's look at the output here. Maybe it will be better. So this is the statistics. There is no prediction interval. Maybe it's in the C3. I'm looking at oh, that's a C3. But if I look at the rpart, oh, this one. Okay, so thank you. So this one, what it will do, it will show you this one. It will show you how many students are at risk and how many are not at risk. It's a percentages. So take a look at this here, the dominant class at risk. So we have 0.56, so it means that I have about 56% of students who are at risk and who are not at risk, sorry, and 43.5% of students who are not at risk. That's what it is. It gives me the breakdown, right, if you will. It's percentage of records that are at risk and that are not at risk at every single node. That's what it's doing. See, like in here, for instance, the root node, right? It's gonna give me, see, the not at risk, right? It's dominant. The second number is a not at risk. Oh, good. I'm glad that I was able to answer the question. Okay. So, well, the reason why I like the R part is that it's kind of a little bit easier to read. Okay. But the ctree method was, in fact, the first one that I figured out how to do. So I'll tell you the secret. Long time ago, many years ago, I wrote the exercise, the first draft, and I was learning R at the same time, and I picked the method that I learned first. But it turned out to be that it was a good one for the exercise. But for the assignment, well, I decided that, look, I'm going to show you two, because the sessions that we're doing should add value to the readings, right? It should add value to the walkthrough. It should not be replacing the walkthrough, right? So we want to make sure that what we do, in addition, it adds value, right? Okay, and another thing is that you might want to watch this more than once. Well, I say it about most of the lectures that I do, but sometimes certain things you need to listen to it twice to get a better understanding. Then you might be able to, you might have more questions, right? That you put in your discussion forum, discussion board, right? Okay. So, but I'm gonna give you the slides, and I'm gonna give you two files with the code, R code, and I'm also gonna give you the copy of the data. I will email everything to the faculty, and they are going to post in a classroom. Okay, but let's see if we have more questions. Okay, but just in general, yeah, you would probably want to, well, as a student, I had to do a project where I had the data set and I had to run 2 to 3 methods and then compare the findings to see which method works better. Then I also had to read the related studies and discuss what they do, compare with my findings, etc. So I had the same course, but in a little different format, the data mining. Since my degree is in a DBST, and one class is the same, something like data 630, but they, instead of bunch of assignments the way you do, they had a midterm final and a big project and a small assignments. So, but the big project is you have data and you run different methods and you compare the findings and also the findings with related studies. So all different approach. Yeah. But I guess, yeah, you do what works for you, you know, and also look at the assignment requirements. Okay. Check with instructor because he will be grading, but he's aware that, well, in this presentation I should too, because the presentation should add value to the readings and to the homework. It should not repeat the walkthrough, right? Okay, so, and I wanted to say that in 2 weeks we're gonna have another class on neural network. Okay, usually I do one session, but this semester I made an exception. The reason is there are so many changes in R version 4. There are so many differences, and another reason is because the slides, we are UMGC. I had to change the slides, but I want to make sure that the slides match what is shown in the recording. Okay, so there are several reasons. Okay, so you're lucky. You get extra lecture. Okay, so are there any more questions, guys? Oh, most welcome, most welcome. So I hope all of you guys will be able to attend another session in 2 weeks. Okay, I'm gonna then, if there are no questions, I'm going to stop this recording and okay, I stop recording. Then